Hi students, in this video I will solve question 7 and question 8 in this past paper. Pearson Edixcel Level 3 GCE Mathematics Advanced Subsidiary Paper 1 Pure Mathematics, Wednesday 16 May 2018. Question 7. In a triangle ABC, ABC, side AB has length 10 cm, side AC has length 5 cm, and angle BAC equals theta, where theta is measured in degrees. The area of triangle ABC is 15 cm squared. Find the two possible values of cosine theta. Area is 15 cm squared, so the law for the area of a triangle is half the product of these two sides times sine the angle confined between the two sides. Multiplying both sides by 2, ten times 5 is 50. Dividing both sides by 50, this cancel out, so sine theta equals 0.6. Now, if the angle is acute in the first quadrant, its sine is 0.6, and if it is obtuse, so it is also has the same sign. But for the cosine, in the first quadrant, the sign is positive, but it is negative in the second quadrant. So the corresponding values for cosine theta, we use this identity. Now here, 0.6 squared plus cosine squared theta equals 1. Taking the square root for both sides, so cosine theta equals either minus 0.8 or positive 0.8. Given that BC is the longest side of the triangle, find the exact length of BC. if BC is the longest side, so this angle must be the obtuse angle. That is, we have to use this value for cosine theta. So in the law of cosines, BC squared equals AB squared plus AC squared minus 2AB times AC times cosine theta equals here 10 squared plus 5 squared minus 2 times 10 times 5 times negative 0.8. $100 plus 25 minus by minus is positive, and this is 100 multiplied by 0.8 is 80 equals 205. So BC equals the square root of 205 and using the calculator, the square root of 205 is 14.3 equals 14.3 rounded to 3 decimal places, centimeter. Question 8. A lorry is driven between London and Newcastle. In a simple model, the cost of the journey £C when the lorry is driven at a steady speed of V kilometers per hour. C equals 1500 over V plus 2V over 11 plus 60. A, find according to this model the value of V that minimizes the cost of the journey. In this case, we derive this formula and equalize the first derivative to 0 and solve it for V. So the first derivative, f prime, f of V prime equals dc by dv equals minus the derivative of 1 over V is minus 1 over V squared plus 2 over 11 plus 0. Derivative of 60 is 0. Now we equalize this to 0. Now rearranging, we find that now by cross multiplication, 2V squared equals now V squared 1500 times 11 over 2. So V is the square root of this. No, this is the sign of the square root. We multiply 1500 by 11 and divide it by 2. Hmm. $90.8 rounded to 3 decimal places. 90.8 kilometer per hour. This is I. This is A, I. Now double I. The minimized cost of the journey. We use this formula, and substitute for V this speed. C equals $1,500 over 19.8 plus, use the brackets, 2 times 90.8 over 11, close the brackets, plus 60. And this is the minimum cost, 93.03 pound. Now B, prove by using d2c over dv squared that the cost is minimized at the speed found in AI. In this case, we want to use the second derivative for the equation, for the formula of C. So the second derivative f of v double prime equals d2c over dv squared. And this is equal now the first derivative is minus first derivative equals minus 1500 over v squared plus 2 over 11. So the second derivative for this is, now we write it as minus 1500 v to minus 2 plus 2 over 11. So we take this power, this minus times minus 2 and decrease the power by 1. So it becomes v minus 3 equals, this is positive, and this is 3000 over v squared, over v cubed. Now substituting for v equals over 990.8 cubed. And this is positive. This is positive. Let us check by the calculator. 3,000 divided by the cube of 90.8. So equals 0.004. Now, which is positive. So when this second derivative is positive, this means that this point is the minimum. So thank you for watching, and bye-bye.